Hello students, this is Coach Steele. I'm sorry today that you're not getting to hear Mr. Pierce, but I figure you've heard Mr. Pierce enough. So anyway, I'm going to give you some notes on stars and galaxies. You guys should have your note sheet in front of you to follow. And we will start by looking at the learning goals. Please pay a close attention today to the underlined portions of each slide, as this will really help you in filling in your notes. I can describe the components of the universe, such as stars, nebulae, and galaxies. I can distinguish between the three types of galaxies. I understand and can interpret the HR diagram. I recognize that Sun is a medium-sized star and is thousands of times closer than any other star. So these are the learning goals that we're going to be speaking of. We're going to start with galaxies. Galaxies are large groups of stars, gas, dust, and solar systems, all held together by gravity. The first type of galaxies are spiral galaxies, and they have spiral arms that wind outwards from the center, as shown above here, and you have a picture of these in your notes. The second type is elliptical galaxies, which are large 3D elliptical ellipses or circles, such as the one you see in your notes. And the third type are irregular galaxies, and these are just many different smaller shapes, and they can really vary. And you have a picture of those in your notes as well. Okay, our galaxy is called the Milky Way. Milky Way galaxy has several things we're going to talk about quickly about our Milky Way galaxy. First of all, it is a spiral galaxy. It contains about 4 billion stars. It's part of what we call a local group of galaxies. Its diameter is about 100,000 light years. And the reminder here in bold is that a light year is a distance, not a time. And light can travel, a light year is about 9.5 trillion kilometers. The Milky Way galaxy is so large that our sun orbits the galaxy center every 240 million years. Okay, next we're going to talk about stars. A star is a luminous ball of gas and plasma held together by its own gravity found throughout our universe. Our star's composition, which means makeup, can be found with what we call a spectroscope. Also, stars can be found in groups arranged in a particular shape called a constellation. Okay. This next portion is about stars still, but we're going to talk about something called the HR diagram. So HR diagrams are used to show the relationship between a star's color, temperature, and brightness. Again, they'll show a relationship between a star's color, temperature, and brightness. First of all, if you look at the left-hand side of the screen here, with color, you'll understand that color is related to temperature. And this is not a very good picture of an HR diagram, but on the next slide I'll show you a better picture of an HR diagram. But you'll notice that the colors, blue, white, should represent hot, as we have here. And if it's a red-orange in color, that should represent cool or cooler. And if it's yellow, that's the same as the sun, and that's going to be around the middle area of the HR diagram. Okay? If you look at the bottom of the screen here, brightness is also kept on the HR diagram. And absolute magnitude is the amount of light a star actually gives off. And the brightness of a star, a term that's used also, is called luminosity. So absolute magnitude is amount of light the star actually gives off. Okay, here's a better picture of an HR diagram. This one you can actually see on the left side that this is brightness of the stars or luminosity, And across the bottom are different colors, different temperatures of stars. And you'll notice the highest temperature is on the left at 40,000, and 2,500 is over on the right, which would be the cooler side of the HR diagram. And you also notice the HR diagram is basically just a graph with all of these stars on it. Okay, the biggest portion of stars on the HR diagram fall along the middle, and we call these the main sequence stars. Then we'll also be talking about the white dwarfs down here that are hot and not as bright, and we'll be talking about the giants that are brighter but not as hot. Okay, so the next slide is about types of stars. Stars are grouped together on the HR diagram by their temperature, which is on the horizontal axis, we just looked at that, and luminosity, which is on the vertical axis. And again, that means brightness of the star. Okay, some categories or types of stars are main sequence, giants, supergiants, and white dwarfs. And our sun rests in the middle of the diagram, which would be a main sequence star, and it's the star that everything else is compared to. Okay, the next term we're going to look at is a nebula. I have a couple of pictures on the screen here of a nebula, which is a large cloud of gas and dust where stars actually originate or begin from. You also have a picture of a nebula in your notes. It's a bit small. These are actually in color, so you can see them a little bit better there, of all the gas and dust that originates in the nebula. Another type is a black hole. A star explodes as a supernova. If the remaining core of the supernova is 3 times bigger than our sun, its mass collapses to a point of no volume. The gravity is so strong that nothing can escape, not even light. The gravity is so strong that nothing can escape, not even light. And there's a picture in your notes, just as this one, of a black hole. All right, moving on. Other universe parts and terms you should become familiar with. If you'll notice in your notes, the definitions of these are written. If you'll just stay with me and keep in or write in the terms. The first one is comet. That's frozen gas and dust. The next one is called meteoroids. These are small rocks and other solid particles that move through space, and most are smaller than a grain of sand. So meteoroids are very small. Meteors. A meteoroid that burns up as it enters our atmosphere, causing it to glow. These are what we actually commonly call shooting stars. A meteorite is a solid meteoroid that actually hits Earth. Some have formed circular depressions in the ground called meteorite craters. And the last one is called an asteroid. Small pieces of rock, usually found in the belt between Mars and Jupiter, will be called asteroids. Okay, and to close this out, we're going to review again a little bit of information about our sun. So again, our sun is a medium-sized star near the edge of a disc-shaped galaxy, our galaxy that we call the Milky Way. These are also called main sequence stars. Medium-sized stars are main sequence stars, which make up the majority of your HR diagram. And then the last thing about the sun that you need to understand is that the sun is thousands of times closer than any other star. Thank you guys for listening. We'll see you guys next time.